Okay, so let's do this fairly quickly. We've got about 12 or 13 minutes, so we can cover some of this at least. We probably won't get to the practice until Monday, I'm guessing. So we'll probably have to combine single replacement and double replacement, which they're very similar, so that shouldn't be too big of a deal. But as far as the sets, we've already talked about A and B, right? A is synthesis, B is decomposition. So then what did we decide that set C is? That's the single replacement, all right? So those are the ones we're going to focus on right now, okay? Now, let me just talk about something quickly, because I think this helps sometimes. And this is actually, I feel like this is a question somewhere on here. Maybe not. No, I don't see it. Okay, anyway, I think it's a good question to ask. Can you come up with some sort of analogy for this first set of reactions? Think about something in life where it kind of looks like maybe a synthesis. Maybe an analogy from relationships, possibly. Yeah, this is a love story, right? Okay? Synthesis is a love story. Or, you know, one of those movies where, you know, guy and the girl meet, they fall in love, and, you know, whatever, insert your movie there. But that's a synthesis reaction, right? Because you've got two things combining, okay, and they're becoming one. So that's a synthesis. It's a love story. Well, if that's the case, then what's a decomposition? This is the Beatles, right? Okay? You guys are too young to, like, get that reference, maybe, but if you don't, you should check out the Beatles. Everyone should listen to all of their albums at some point in your life. Okay, decomposition reaction, it's a breakup, right? Okay, you start with one thing, and then it breaks apart into two things, or more, which is strange, but, you know, I mean, don't take the analogy too far. All right, set C, we said, is single replacement. So based on those analogies, what is single replacement? I don't think this show is on TV anymore. Did any of you ever watch the show Cheaters? That's what's happening here. You can probably kind of guess what I mean when I say cheaters, right? Okay? Yeah, so this Fe is in a relationship with the Cl at first. Well, the zinc comes in, kicks out the Fe, and now the zinc's with the chlorine, right? Yeah, this is controversy right here, okay? This is Cheaters. So now you've got like a film crew. This is like the Cheaters show. A film crew's following these people around as they catch them in the act of being out on a date with another person. And then they just, you know, publicly start beating on them and stuff like that. That's what happens in this Cheaters show. It was filmed in Dallas, right? So it's, well, reality, right? I'm sure they tell these people, you know, just go after him. Just go after him, you know. I don't know. Anyway, point is, don't look behind you. Okay, point is, you just need to knock him over tonight. Just once. Just knock him over. You know, not like real hard. Okay. All right. So anyway, set C is a single replacement, and that's kind of like a cheaters thing, all right? One is replacing the other one, okay? Now, there is kind of an order to this on the periodic table. Some of the elements are, let's say, a little more charismatic, a little stronger, maybe a little more appealing to the ladies. I don't know, okay? There are certain elements that will be able to replace other elements on the periodic table. So what I'm going to give you now, if I can find it, is called an activity series, okay? And this activity series basically tells you who's stronger. Superman. Well, I don't know. Gamma radiation. Sorry, for those of you watching the video, now there's a debate about whether the Hulk or Superman is stronger. And I just felt like I had to weigh in on that one. Huh? Superman better he's strong, he doesn't have to get all big and stuff. Yeah. Okay. So what you have here, again, it's called the activity series. If you're on the side that says soluble ionic compounds, just forget about that. We're not worried about that, okay? It's the side that says activity series of metals. And what this means, basically, Lithium is the big, strong guy on the beach, right? He's going by, he's kicking sand on the little guys and stealing their girls. Okay? That's lithium, all right? So lithium is able to basically replace any of these other metals when they're in a compound, okay? Poor gold. That probably explains why gold never really forms a compound with anything most of the time, because it just gets kicked out of the compound if it does, right? And that's actually why gold is such a precious metal, because it doesn't combine with other things, right? So that's why we use it for rings and stuff like that. It doesn't react with oxygen like a lot of these other metals do, and doesn't tend to rust. So gold is down at the bottom here, and if gold's in a compound, then pretty much any other metal up here can replace it, okay? So that's how that works. Now notice, everything on this list, so the iron's being replaced by zinc in this first one, right? You guys see that? So look at where iron is and where zinc is on this periodic table. Sorry, on this activity series. Yeah, iron's below, the zinc is above, right? So the zinc is stronger, it's able to replace the iron. Does that make sense? Okay? Now, let's say that the situation is reversed. Let's take the flip of this reaction. So you've got the zinc with the chlorine now. And let's say that the iron tried to come in and replace the zinc.
How do you know which one is trying to replace?
Well, okay, so if you look at the reaction here, the question was, how do you know which one is trying to replace the other one? Look at the one that's in the compound on the reactant side. The iron's in the compound, right?
Yeah.
So then the zinc would be trying to replace the iron. Okay, and this is another thing that we'll get to this if we have time, okay? But a positive ion will always replace a positive ion, okay? I don't know if this will help you. If we're staying with our analogy here, you can maybe think of the positive ions as the guys and the negative ions as the girls, right? So if iron and zinc are both guys, then the zinc's going to replace the iron and try to steal the girl. Does that make sense? Okay. So let's say, and here's my original question, let's say that the iron, if we're doing this backwards and we're starting with what's on this side, and the iron tries to replace the zinc, is that going to work? No. Zinc's going to be like, nope, can't do that. And so then the iron just kind of walks away, you know. Has to find some other metal that it's stronger than, that it can replace, okay? So that's how that works. Now, if I wrote this for you, if I wrote Fe plus ZnCl2, and I asked you to predict the product of this reaction, you're going to tell me no. Okay? Or really, you should probably write no reaction. Okay? That's not going to happen. Okay? Because of this activity series, because the iron's not strong enough to replace the zinc. Does that make sense? Okay. Now you can look at all of these down this list and they all work the same way. Calcium replaces aluminum because calcium is higher on the list than aluminum is. Okay? Copper replaces magnesium because copper, wait. Sorry, magnesium replaces copper. I knew that didn't sound right. Magnesium replaces copper because magnesium is higher on the list. This is where it gets a little tricky, okay, because I gave you just the metals list. On this second one from the bottom here, the chlorine plus the sodium bromide, it's actually the chlorine. So, you know, using our analogy, the girl is kicking the girl out of the relationship and stealing the guy in this one, okay? And I didn't really give you an activity series for the non-metals. So you're just going to have to take my word for it that when I give you something like this, where a non-metal replaces a non-metal, it just happens, okay? You're just going to assume that it happens. Man, coming from all directions here. Yeah.
I'm going to my Banner's room and get my pile up under the...
Okay. All right, so does that kind of make sense with the single replacement?
Yes.
All right.
Okay. I think that's about as far as we're going to get for today, talking about the activity series. That's a good place to stop. We'll finish talking about the single replacement and the double replacement on Monday, okay?
Anyway, that was like...